and he's at the telescope, the 48-inch Schmidt telescope camera on Mount Palomar. And while he was a grad student in the early 1950s, he was the observer taking images, plates, for the new famous, well, the soon-to-be famous Palomar Observatory Sky Survey that took place started in the very late 1940s and continued through the 1950s. And he was the one, he took the plates and then he examined them to make sure they came out okay, there weren't any obnoxious streaks on them, and they had to redo the plates. And when he examined the plates, he noticed there were some interesting dim objects on the plates that he knew had not been cataloged before. And one of the types of objects he realized quickly were on the plates were very faint circular objects that looked like planetary nebulae. Okay, much fainter than ones we're familiar with, like M57 or the Dumbbell Nebula M27. And he started listing them all as he found them on the various plates, and in 1955 published a list of 73 planetaries, new planetaries that he discovered, basically because he was the first one to look at the Palomar plates. And about a decade later, he published a second final list that had 86 planetaries, new planetaries that were discovered. And they're simply known by Able 1 through 86. So the question comes up, well, why weren't they known? Why either weren't they discovered visually or photographically before the 1950s? Well, many of his discoveries are highly evolved planetaries. They're old, ancient, senile planetaries, if you will, in which the planetary had formed quite a while ago, and at this stage, the gas or the envelope around the original white dwarf star had traveled a far enough distance from the central star that it was no longer being ionized, and it was actually becoming just part of the interstellar medium. And many of these have a very low surface brightness, and amateurs and visual observers before this really couldn't see them without having special filters. And filters were kind of the key for amateurs to be able to observe them, namely an oxygen-3 filter, and later another filter that Lumicon sold called a UHC filter that came along in the early 1980s. And fortunately, I was friends with Jack Marling at the time, and we actually tested out his early filters in the early 1980s. And of course, the objects we chose to look at to see how his new filters would work were these Able planetary nebulae. So here's one example. I tried to pick specific examples, mostly that are visible in the summer sky. This is Able 39, that's the number, and it's in Hercules, and it's a perfect circular spherical bubble, 3 arc minutes in diameter, pretty decent size for a planetary nebula, much larger than the Ring Nebula. And it's at a distance of 5,500 light years. The actual diameter of the planetary, the physical diameter, is 5.5 light years. And it does have you may not be able to see it, but there's a star right in the center that's a pretty dim, the white dwarf is a pretty dim Mag 15.7 star. And anything I talk about its visibility is based on my own personal experience. So I wrote that it's faintly visible unfiltered in an 18-inch telescope. It's a fairly easy object from a dark sky with an 18-inch telescope with a filter. And if you use a filter, I've even glimpsed it in an 8-inch telescope. I don't personally have an 8-inch telescope right now. I have a 24-inch telescope, but I have an 8-inch mask that I can put on the telescope and see if it's visible, and that's what I did. Here's another planetary. I wish you could see this a little better here. There's a ring here, and it has actually a reddish or pinkish rim along here, on the image anyways. And there's kind of a bright spot on the very top of it, and there's a central star in the middle. So originally people just thought this was a planetary, and a little bright spot right on the top right here was just a knot in the planetary. That's what was assumed until relatively recently. And finally they took a spectrum of that knot, and it turns out that knot is not part of the planetary. It's a background galaxy, has a high redshift, at 250 million light years, that's shining through the rim of the planetary. In other words, that bright spot is 10,000 times as distant as the galaxy itself, okay? And it's also quite unusual central star. You can't, even if you were up close here, it would look like a single star, but it's actually a binary, and it's a barium-rich binary, which is actually quite unusual. Barium isn't produced on the main sequence. Iron is usually the heaviest element that is produced on the main sequence, but in later stages, barium can be produced. The white dwarf is the star, the central star, the hot central star, is the star that produced the barium, and it polluted the main sequence star with its heavy elements, including barium. So visually, what can you see? The planetary with a filter isn't, again, with my experience with this is with an 18-inch telescope and larger, unfortunately, not smaller ones, but you can see a weak ring visually, and you can see a knot. You definitely can see a knot on the north side of it, and with a little larger telescope, you can actually see that knot extends into an edge-on galaxy. It does look like a galaxy on the top. So I call it, I'm not sure, well anyways, I refer to it as the diamond ring planetary because there's the diamond on the top and it's an annular planetary. One more that's in Sagittarius. Let's see. Okay, I forgot I did this on a few slides. Okay, this is another able planetary that's in Sagittarius that I call peanut in a shell. The central part you probably can see right in here is the peanut, but you can't really I don't know, I can't see it from my angle here, but there's a faint outer wings that sort of kind of stand in for a shell on the peanut. And so anyways, it's a double shell planetary with a peanut shape and a central binary central star. Also, it's one of the brighter able planetaries. It sort of looks like a boxy oval. I've seen it in a 13-inch. I also have a 14-inch telescope. It's not too difficult in the 14-inch telescope. And it has a very faint central star, like several of the other planetaries. Okay, here's George Abel a little later in life, kind of when I saw him. He was a very well-known professor of astronomy at UCLA when I went to school there in the late 1960s. And I don't know, he had a pretty popular textbook, a beginning level textbook that maybe some of you saw or purchased called Exploration of the Universe. It was by George Abel. And his PhD dissertation, actually, was on the distribution of rich galaxy clusters. So, how did he discover these rich? He discovered these rich galaxy clusters, again, by examining the Palomar Sky Survey prints that he had first dibs on. So, before 1950, only a few dozen clusters, galaxy clusters. What's a galaxy cluster that people are familiar with? A Virgo cluster. But there's several other fainter clusters. For example, there's a cluster in Coma, Berenice is referred to as the Coma cluster. One in Perseus called the Perseus cluster. Well, he discovered a number, in fact, 2,712, he cataloged galaxy clusters that he found on the Palomar Sky Survey plate. You can tell this had to be examining plates very carefully, and he was using a little hand magnifier, like an 8x magnifier, because the galaxies themselves were really, really tiny on the Palomar Sky Survey plates, which are 6 degrees across in size. And he sort of cataloged them based on size, galaxy counts, and how rich they were, and he estimated a distance. But they had no way of computing the redshift of these things, so basically he put them into bins, like distance class 0, which were the closest, distance class 1, 2, 3, 4. So we had 4 levels, or 5 if you want to count 0, of distance classes, and that was just based on how bright the 10th brightest galaxy was in the cluster, so it was purely visual. Okay, are we getting sunlight on it now? Oh, yeah.
Everybody stand up.
Oh. Oh, well, wait 1 second. Jump up and down, Richard. Maybe I'll.
Yeah, I'll just jump up and down real fast.
Can we hang a limit?
Yeah, tweak your ladder to move well forward so I don't kill you with the van.
Move backwards. You won't see it.
You're running around in the back.
If we just turn one of the tables up on that.
The sky is clear.
Takes that high band. Oh, there we go.
Keep going.
Keep going.
Yeah! Okay, so here's an example of a galaxy cluster, a rich galaxy cluster, pretty faint one, but famous also, that is visible in the skies here tonight. In fact, I know Akash, sitting in the front here, was observing it last night around 2 o'clock, right?
Right.
Yeah.
Maybe a little earlier, 1 o'clock maybe.
In fact, if I'm not mistaken, from what I was hearing, I think you were observing that galaxy right there.
Yeah, I was looking for the four
club.
four arbs.
The club, right?
Yeah, I was looking for all the 4 arbs there, the golf club included.
Yeah.
Yeah.
So this is somewhat of an unusual galaxy cluster because it has an irregular structure and it has a large percentage of spiral galaxies. Often galaxy clusters are dominated by elliptical galaxies, but up to half the galaxies in the Hercules cluster are either spirals or irregulars. And this is one of the most distant clusters you can see, say, in a 12-inch telescope. It's about 500 million light years away. And I've seen 36 cluster members I've logged 36 different cluster members in my 18-inch. There's an amazing number that are visible in Jimmy Lowry's 48 inch. And that's one cluster here. And this is another more, that was about a $500 million. To go to 1 billion, we can go to Able 2065. There's a photo of this in Burnham's Celestial Handbook that really, I don't know, fascinated me when I saw an image of it years and decades ago. And I always said I wanted to see that object. And I think in that, in Burnham's, it might say it's impossible, it's beyond amateur telescopes or something, which didn't turn out to be true. But it has over 400 members that are 16th magnitude and fainter. And someone I wrote at one point, perhaps it's the most difficult object for amateur scopes. I forget who made that quote, but it probably is one of the most distant cluster that's visible in an 18-inch, where you're seeing at least several members. I've seen 6 in my 18-inch, and I wrote an article in Sky and Telescope. I don't know, I guess I forgot to put the date on here that the article was, but I think it was in the early 2000s.
Steve,
Yeah.
I've seen 76 members.
76 members, yeah. Well, I wrote here, I guess, dozens visible in a 48-inch. Yeah. That's okay. So, I'm going to change to a different type of objects, but you'll get a theme here that a lot of them were discovered on the Palomar Sky Survey. So that's Palomar globular clusters and Terzon globular clusters. In fact, last night I was looking for a Terzon globular cluster, and I'll have to admit I was unsuccessful on it. And I think you've seen it actually. Terzon 9. Does that ring a bell or not?
I have to look at my notes, but I think yes.
Yeah. Anyways, in 1955, once again, George Abel published a list of 15 new, extremely faint, relatively faint, globular clusters that were found either by him or another Caltech astronomer, Albert Wilson, on the Palomar Sky Survey. As it turned out, 2 of them with catalog numbers IC 1276 and NGC 6717 were previously discovered. So there was really 13 new ones. And then in the late 1960s, an Armenian astronomer, Agop Terzon, discovered 11 new globulars that on red sensitive plates while he was surveying the center of the Milky Way. And they had been previously missed because that region is extremely dusty, so the globulars were extremely reddened. And turns out, I'm going to probably talk a little bit more about this later on, but 2 of the Terzons are not from our galaxy. They're actually globulars that were captured in a going out of business sale, so to speak, of the Sagittarius dwarf spheroidal galaxy. I think I'm going to talk about that a little bit later. So here's like a typical Palomar, this little smudge in the center here. That's Palomar 8. Abel discovered that in the 1950s. And it can be glimpsed. This is one of the brighter ones, perhaps one of the 2 brightest, I think. And it can be glimpsed in a 70 millimeter refractor, and I have resolved about a dozen stars in an 18-inch. In my 18-inch, it's a former 18-inch, I don't have it currently. But actually, Richard mentions that I'm very interested in astronomical history. Well, I've gone through the observing logbooks at Lick Observatory, and by examining E.E. Barnard's logbooks when he was a visual astronomer in the 1890s at Lick Observatory. It turns out he never published a discovery, but it turns out I found in his logbooks the visual discovery with a 12-inch of Palomar 8. He discovered it visually, made a little sketch of it, and even made the comment in his notebook that it was likely a globular cluster. But he really wasn't that interested in publishing the discovery, never did, and so it went unknown until the 1950s, believe it or not. Why didn't he publish it? Well, he wasn't going to publish it unless he had an accurate position of the object. He needed a position to be able to put it in a professional journal. And he was more interested at the time of discovering comets, and it would have taken up precious time to try to figure out, to determine the position of it. And here's an example of a Tarzan globular, and I wrote about this I did put the date here. I did write about this in October 2021, and this one is 75,000 light years away on the far side of the galaxy, behind the central bulge, and it's an unusually young globular. It's about 10 billion years old, about 4 billion years younger than most Milky Way globulars, and it used to be a member of the Sagittarius dwarf spheroidal galaxy, which is currently colliding with the Milky Way. You're not going to see it though. It's so large and so diffuse and spread out. The individual members can only be picked out spectroscopically, so it's not something you can observe, but you might have observed the core of the Sagittarius dwarf spheroidal galaxy. The core of the galaxy is actually a Messier object. If you've observed all the Messiers, you've actually observed a former extragalactic globular, and that's M54, is the core of the Sagittarius dwarf spheroidal. This astronomer is Boris Vorontsov-Velyaminov, Russian astronomer, and in 1959 he published the first galaxy catalog based on the Palomar Sky Survey, and it wasn't just a standard galaxy cluster, it was a catalog of interacting galaxies, and he listed, they weren't all new discoveries, some were, some weren't, but he listed 355 interacting systems, and he divided them into different classes. He had sort of an interesting way of classifying them into nests and chains and bridges and etc. And many of his systems were quite deformed, and they actually were the inspiration for Halt Narp to take a look at these deformed systems and eventually produce his atlas of peculiar galaxies later. Vorontsov, the VV catalog, was the inspiration for ARP. So here's an example of a VV galaxy that is visible now, in the summertime, called the Tadpole galaxies. This, of course, is this is a Hubble image. Here's the galaxy with kind of an unusual, here's one tail spiral arm here, and another spiral arm coming off here, and then twisting and becoming a really long tidal tail, or plume down to here, right to the edge of the image. And that tidal tail is 280,000 light years long. So it's a huge tidal tail. So what happened? Well, this galaxy interacted with a companion or another galaxy, it really wasn't known what the collider was, what had caused this strange, very long tidal tail. And with the HST imaged it, the Hubble telescope, you actually can see the collider at the edge of the spiral arm right here. That's the collider. And the collision occurred 100 to 200 million years ago. And this galaxy is visible in a 12 to 14 inch, but you do need a larger telescope to be able to glimpse the tidal tail. That's pretty low surface brightness. Here's a merging pair that's a VV 102. It's also up this time of year in Delphinus, VV 102. I have an article coming out in 2 months in Sky and Telescope, specifically on Delphinus. And this is a fused or merged double system that's colliding, and the two nuclei of the galaxies are very close together. You can't really even appreciate that on this image. They're only 16 arc seconds apart, but which corresponds to about 35,000 light years. But those two galaxies they're well on their way to merging into a single galaxy. And even though they started off as spirals, they'll eventually settle down as elliptical galaxies. And I have glimpsed this galaxy in an 8-inch and resolved the two nuclei right here in my 24-inch. One more. This is kind of an iconic Hubble image of Hubble's Rose, VV 323. Again, here's one galaxy with just these beautiful spiral arms that clearly look something stretched them out, particularly along this side right here. And here's the galaxy it interacted with. And the collisions already occurred. Probably this galaxy at one point, came very close to the top one and is now probably moving away, but will eventually circle back and will eventually merge. So VV 323. So here's Halton Arp, and I wrote about his Arp peculiar galaxies in May 2017. And in 1966, he came out with an atlas that had 338 peculiar galaxies, and he split them into numerous categories: galaxies with rings, jets, interior absorption, dark patches, ejected materials, loops, double galaxies, filaments. To see the galaxies aren't always that challenging, but it can be quite challenging to see the actual structure or detail in the individual galaxies. And he was a very accomplished astronomer at Palomar, a staff astronomer for many, many years, but became very controversial because he proposed a theory that quasars were not at cosmological distances as their redshifts indicated, but that they were actually ejected from much more nearby galaxies, and the high redshift was an effect. He didn't really quite have a full-form theory of what caused the high redshifts, because if it was some kind of ejection, you would think some were ejected towards us and they might be blue shifted, but that's not the case. And he was eventually essentially banned from using the 200-inch on Palomar, and he ended up moving to Germany to continue observations. Sort of fortunate to have dinner once with him in San Francisco. Here's one example of an ARP, which is again visible right now. It's this time of year in Draco, ARP 81, that we call Edwards Galaxy because it was discovered by Edward Swift, the son of Lewis Swift, and remarkably, he was 14 years old. He discovered a number of galaxies, but he discovered this galaxy when he was 14 years old. And very unusual. There are two galaxies here. This is NGC 6622, NGC 6621. There's sort of a bright patch kind of in between them, which is a sort of a young group of stars that recently formed called a starburst. And there's a long one-sided tidal tail that comes all the way down, all the way to this star down here. Quite unique. And in a very large telescope, that is just about what it looks like. One last one. This is another famous Hubble image. It's the antennae, which is NGC 4038, 4039. There are two galaxies here. Here's the core of one of them. Here's the core of the other one. I know it hardly looks like a galaxy at all. These are all freshly minted stars that are lit up along the rim due to the collision. These two galaxies had a closest approach about 250 million years ago, and giant molecular clouds within the galaxies were compressed, triggering all this star formation currently going on. Very bizarre annular shape, and you can see numerous knots along the rim, particularly here in the brighter top galaxy. One last one. This one's called the Penguin and the Egg. It's in Hydra. It's a spring galaxy. I thought I would show this one because it had sort of shows you ARP's interesting ideas. There's a galaxy up here you can see, and it coincidentally it looks like it's pointing either directly towards these two galaxies, the Penguin and the Egg. I think these have another nickname too, I forget what it is, but in any case, ARP called this galaxy in a paper a shred or a jet, and he thought it had been ejected from the collision because it looks like it's pointing directly to the galaxies or had been ejected like this. But once a redshift was taken, it turns out that galaxy is in the foreground right here. It's only 70% the distance of the other two, so it's nothing to do with it. Another group type of objects are triplets. This is another Russian astronomer, Igor Karanshantsev, and in the 1970s, once again on the Palomar Sky Survey, he cataloged triplets of galaxies. And I wrote an article on it in May 2015 with several examples. They're known by KTG numbers, Karanshantsev triplets of galaxies. And he had a southern extension that had 76 more. So 84 plus 76 total, 160 triplets. And I've observed almost all of them with various telescopes. It's kind of a challenging but fun because you get three galaxies in one field of view. Here's an example. KTG 29 in sextants. It's a physically interacting group. Here's one galaxy, second one, third one. All three galaxies, also known as Holmberg 193, are separated. The maximum separation from here to here is only 1.3 arc minutes. It's pretty close together. To give you an idea, the separation of the two components of Alburio, the bright double star in Cygnus, is 35 arc seconds. So if you take three times the separation of Alburio, these, say 3 times, these 3 galaxies would fit in that space. the separation between Alberio, if you could triple it. And I've seen them this close pair separated in my 24-inch. Karen Shensov also did another famous catalog of flat galaxies. What's a flat galaxy? Well, it's just what it sounds like. Very thin, narrow edge-ons. But they're kind of unique in that they do not have a central bulge as many spirals do, like the Milky Way. So, in other words, there's no real significant difference between the width of the galaxy through the center as opposed to along the spiral arms out here. And this image, can you see this sort of looks like loops around the galaxy? Those actually are that's actually tidal streams going around that galaxy, and we also have tidal streams around the Milky Way. They're not visual, but that's sort of a famous image. And this is, it's right, it was an amateur image.
You also
That's
know
correct.
that there's a controversy around it, right? Like that image, they said that it's no longer, there was a paper that said that's not a loop, but there's a single tail, and there's some controversy
Something weird
around it.
going
Yeah.
on there. Yeah. Yeah. So here's one more ultra thin. Was this the one, Jimmy, you were trying to think of the number for UGC 7170? Was that's it, right? That's why I put that on here this afternoon, or added it. That's the one. This is a super thin galaxy. FGC stands for Flat Galaxy Catalog 1379, which is UGC 7170. It's a razor thin edge-on in an 18-inch. It's near the globular cluster NGC 4147 in Coma Berenices, and it's about a 10-to-1 axial ratio. No central bulge. Look how narrow and thin that is. And a slight warp at the ends. Ghostly, exactly. This is Paul Hickson. He did a pretty famous catalog, Canadian astronomer at the University of British Columbia. He's involved with a number of professional projects like the, I'm trying to think, probably he might be the director of one of the large,
Liquid mirror.
yeah. Which mirror?
Liquid mirror.
Yeah. And he produced a catalog, also based on the Palomar Sky Survey, of compact groups that are called Hickson compact groups, or HCG. And there's 100 of them, and several of them are pretty famous, like, I'll show you, Stephan's Quintet. Here's Stephan's Quintet, famous quintet near NGC 7331. There's 5, the quintet obviously. On first glance it looks like there's 4, but 1, 2, this is 2 galaxies merging, and there's the 5th one. Except there's not really 5, there's 4, because this galaxy right here is much, much closer. It's not part of, it just happens to lie along the same line of sight. And I've seen a couple of them in a 6-inch, 4 in an 8-inch, and all 5 of them in an old 13-inch I had in the early 1980s. One more, if you can go up in number, here's Seaford's Sextet, Hickson 79, and there's 6 of them. 1, 2, 3, 4, 5, 6, except once again, it turns out there's really not 6, because this is actually a tidal tail coming out of this galaxy here, the bright one on the bottom, and this one right here is a background galaxy, this little tiny spiral. So actually there's only 4 there. In April, just a couple of months ago, I had an article on Shakbazian compact groups. The designation is SHK, And in 1957, another Armenian astronomer, Romel Shahbazian, found a compact group of red stellar objects that she thought was a distant star cluster. And several years later, another astronomer took a spectrum and determined they were actually a distant galaxy cluster at 1.5 billion light years. And we now know that group is Shahbazian 1. And she cataloged, and colleagues cataloged 377 similar groups. And I wrote about them. The observations in Sky and Telescope, I think I have 3 different groups highlighted that I observed with my 18-inch, including 6 of them in this group, which is Shahbazian 16. I think the 6 might have been 1, 2, 3, 4, 5, and maybe this one up here, 6. In July 2018, I have an article on extragalactic globular clusters. What does that mean? That means globular clusters that are members of other galaxies, not the Milky Way, and not galaxies that were stolen from other galaxies by the Milky Way. You might say, oh, that's impossible to see globulars in other galaxies. Actually, it's simple, believe me. If you're in the southern hemisphere, there are many globulars in the Magellanic Clouds that are as bright as 10th magnitude, that are as bright as typical NGC globulars, and that are resolved into stars. But what about for us poor northerners? Well, the easiest way to see an extragalactic globular is in M31. This is kind of a famous one, the Hubble image of a globular called G1 in globular 1 in M31. And it's resolved by Hubble, but of course it just looks like a fuzzy glow in amateur telescopes, but it is visible. And several globulars are visible in the Fornax dwarf galaxy, and a few in M33 and in Barnard's galaxy, and in a few other local group members. Another group, pre-planetary nebula. These are objects that are rapidly evolving into becoming planetaries. They're a very short-lived phase that, because of that short-lived phase, a few thousand years, there's only a relatively small number of them that are known, because they don't last very long before they become regular planetaries. And one good example is one that's up this time of year, that's called Minkowski's butterfly. That's in the constellation Cygnus. And I wrote about preplanetaries in June 2021. Unfortunately, the central star is not a white dwarf yet, and it's not hot enough to ionize the gas that was expelled during the giant phase or asymptotic giant branch phase. And so it shines by reflected light, so you can't use a filter on it. You just have to observe it at high power. And the wings of here, going to the right and left, are definitely visible in an amateur telescope in a dark sky, as well as the central star. But of course, just I have to say this, you don't see these colors here. I assume and this is not ionized gas. You might think the green is ionized oxygen, but that isn't the case. This is one that's visible in the southern hemisphere, a bright one that you can't see from here. Unfortunately, it really does look like sort of like a bow tie in the southern hemisphere, called the Boomerang Nebula. It was discovered in the 1970s. It's in the constellation Centaurus, and it has 2 lobes, again shining by reflected polarized light. I think these colors have to do with the degree or angle of polarization. In 1995, studies revealed that it was the coldest known place in the universe. Actually, in the interior, only 1 degree Kelvin. The ultra cold carbon monoxide gas apparently has absorbed the 3K background radiation. And yeah, and I think that is still holds the record. And though I've seen the wings in a 14-inch from Australia. I think I just have 1 or 2 more here. This is an article I wrote in October 2023. The title was Milky Way and the Seven Dwarfs. And what are the seven dwarfs? Well, they're dwarf galaxies, specifically dwarf spheroidal galaxies that are satellites of the Milky Way. But let me just back up a minute, and the local group of galaxies are basically the group of galaxies that are dominated by the Milky Way and M31 and M33. And there's a whole bunch of satellite galaxies like M32, M110 around the Andromeda Galaxy. And we have satellite galaxies like the Large Magellanic Cloud, the Small Magellanic Cloud, and a number of dwarfs. Probably the first dwarf, spheroidal dwarf that was discovered was by Harlow Shapley in 1937. And probably can't see this, but there's a graininess in the center here, and that's the Sculptor dwarf. It's so basically low surface brightness, low mass, low luminosity, that it was unknown up to that point. And at that point, it wasn't really known, is it a huge globular cluster or another galaxy? And it was determined spectroscopically to be another galaxy. Now we know there are 60 local group members in the entire local group. Many of them go around M31. And many of them were discovered on sky surveys even recently. And here's a really dim one I wrote about called there's one in Draco, by the way, called the Draco dwarf. But this is the Ursa Minor dwarf. Even on the image, you can't even tell there's a galaxy here. I mean, there's a very slight increase in stellar density around here. And that was discovered in 1954, again on the Palomar Sky Survey. I have seen it from here with my 18-inch several years ago, but it was a very difficult observation. Oh, last one. May 2019, the article is Join the Billion Light Year Club, and that is objects that are 1 billion light years or further away. Okay, so first of all, there are some galaxies that even in an 18-inch telescope at 1 billion light years, you can see regular galaxies. One of them is called IC 1101 as an example. Well, I kind of talked about a cluster that was the Corona Borealis cluster. That's almost about 1 billion light years, and it is just visible in an 18-inch. There are some super luminous elliptical and spiral galaxies. This is one of them. There's a whole catalog of them called the OGC, Ogle Galaxy Catalog. And this is one example. This galaxy is at 1.8 billion light years. Oh, that's one I've seen. But the easiest way to join the club is with a quasar like 3C273, which is the first and most famous discovered quasar. First discovered as a radio source. That's why it has a designation. 3C is a radio catalog. And in 1963, Martin Schmidt just found that the redshift, it had a high redshift, implying 2 billion light year distance, and yet it looked like a star. How is it possible something, and it's about between 13th and 14th magnitude, how is it possible something 2 billion light years away can be seen like in a 10-inch telescope? Well, it turns out the energy source is an actively accreting supermassive black hole. There is a galaxy here, it's being masked, but at the center of a galaxy, there is a supermassive black hole as material spirals in towards the black hole, forming an accretion disk. The material heats up, and a huge amount of energy, both heat energy and other particles, are created, and a quasar, obviously, it can completely outshine the brightest galaxies. And I have observed about 3 dozen quasars in my 18-inch, all the way out to 11 to 12 billion light years. And I mentioned a few times my telescope, so my telescope's just on the next row over. It's a 24-inch, you can kind of see the tents here, and that was taken here. And I also mentioned a large telescope, a 48-inch telescope, whose owner is here, but did not bring the telescope. And there I am on a ladder observing on that telescope. That's what it looks like. And the gentleman who took the photo is even sitting in the first row here. Right? Didn't you take
It was
that?
my friend Santosh. Yeah.
He took it?
Yeah, he took it.
Oh,
I don't
okay.
think I took it, but yeah.
Oh, okay.
I was there. Yeah.
Yeah, it was taken in Jimmy's backyard. That's right. It is, literally. Okay, well, I think that's about it.